Hi all, in this video I'm going to go over topic 1 from probability, which is just an introduction to probability. You've probably done a lot of this in past math classes, so this should hopefully be pretty basic. Probability is essentially we're assigning a number to a process of chance. So basically the probability of something occurring is how many times it could occur out of how many total times it could occur. So if you think about rolling a six-sided die and you want to know the probability of rolling like a 5, well, there's 1 5 out of 6 sides. That would be 1 out of 6. One thing you probably have not learned in the past is uniform probability. And that just means if you think about if people are wearing uniforms, they're all the same. So all the outcomes are equally likely to happen. A couple of examples: flipping a coin, that is uniform because the probability you get heads or tails is 50-50. Probability of rolling a dice, that's uniform. The probability you get any one of the 6 sides is 1/6. The probability of spinning the spinner, the probability you get one of those 4 colors is 1/4. So these are all examples of uniform. Rolling a weighted die, this is not uniform because you're way more likely to get a 6 than you are a 5 or a 4. So these are not equally likely to happen. So as far as justifying your response, what this would look like would be yes, the probability of heads is equal to the probability of tails. Here, yes, the probability of 1 equals the probability of 2 equals ... the probability of 6. For the third one, yes, probability of each color is equal. And this last one would be no, probability of each number is not equal. Now, going back and talking about the sample space. The sample space is all the possible outcomes. So on a coin, you're talking heads and tails. Those are your sample space. They have these correlate brackets that they typically use. I'm not the best at drawing them. They look like this. For the dice or the die, it's 1, 2, 3, 4, 5, 6. For this spinner, red, green, blue, yellow. And for this weighted die, it would just be 4, 5, and 6. You're just going to list the possible outcomes. It doesn't matter that 6 is more likely to occur. We're not going to put 6 3 times there. So on the next page, you're going to see some examples of the same thing. Pick a flavor of ice cream. What's the sample space? Are the events uniform? Same thing here. So pause the video now, work through the top half of this page up until sample space, please. Going over these questions for you. Ice cream flavors, the sample space, there's 3. There's chocolate, vanilla, and strawberry. And yes, this is uniform because each probability is 1/3. Determining the sex of a baby, the sample space is male and female. This is uniform because the probabilities are equal. The sample space for the marbles in the bag, it's kind of hard to see. You have red and blue. That's your sample space. These aren't uniform events because the probability that you get a red is not the same as blue. There's more red than blue. For the spinner, every single number occurred once. You might not be able to see, now I'm looking at this copy, some of the numbers. That's all right, but each number occurs once. This bag, you have less green than you do white and blue marbles, so they're not uniform. Tile, kind of like Scrabble tiles, like calculator, but we're only listing the repeated letters once. But this is not going to be uniform because the letter C repeats, L repeats, and so on. Same idea with blab, BLA, not going to be uniform because there's more B's, more A's in algebra, not going to be uniform. So at the bottom of page 2, just kind of highlighting a sample space, it's just helpful to determine the probability of an event. We can list sample space out like a list. We can do it with a tree diagram. As we move on to the next page, we can do it systematically. We can do it with something called a product table. So if you think about, if we roll 2 dice, say we roll a red die and a green die, on each dice we could get a 1 through 6. And if we make like ordered pairs with the red die coming first and then the green die coming second. You can see here like, oh, 6, 1. That's a 6 on the red, a 1 on the green, and so on and so forth. A tree diagram, there's 36 outcomes here. That's why the font is like size 2. You could roll a 1 through 6 on the first die, and then on the second die, you could roll a 1 through 6, and they're looking at the sum specifically. A systematic list is basically if you pick a pattern and list things out. So if you flip a coin twice, you could go heads, 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 tails, tails, heads, tails, tails. So we're going to move into tree diagrams a little bit later in this lesson. So what I want to do is model a couple of examples here on page 3, and then have you practice a couple of these. So if we take a look at question number 3, what's the probability of rolling a prime number with a single die? So if you think about rolling a die, your options are 1, 2, 3, 4, 5, 6. Prime number is 2, 3, and 5. Prime numbers only have the factors of 1 and itself, so each of these numbers has exactly 2 factors. So there's a total number of 6 outcomes, out of which 3 are prime numbers. Now, here's a little note. You don't have to reduce fractions. If it's a multiple choice question on an assessment, you might not see 3/6, you'll probably see 1/2. But if it's a short answer question, this is perfectly acceptable. So let's take a look at one more here. Question 2. The tally below shows the number of times that Jim and Rob won games of checkers. What is the probability Rob beats Jim in future games? So what we want to do is look at the experimental data that we have. If I tally these up, Jim has won 9 times, Rob has won 6 times. So if we want the probability that Rob's going to win, we have a total of 15 games played. That's going to be our denominator, out of which Rob has won 6. So we're going to predict that the probability that Rob beats Jim is 6 out of 15. So what I would like for you to do now is finish up page 3. So these questions on page 3 and question 7 on page 4. So pause the video, work through those, please. Let's go through those. Question 1, you have to sum up all the marbles. There's a total of 44. 14 are blue. They're not marbles, they're actually jelly beans. 14 out of 44. You're going to have to simplify that or reduce that. You can do that in the calculator, is 7 out of 22. Question 6, total number of marbles is 12. What's the probability of drawing a teal? 5 are teal out of the 12 total. Question 7, we want to know, based on these observations, the experimental probability. Well, we had 18 days of rain, and we want to know the probability it's going to rain. 18 out of 30. Or 3/5. November has 30 days, or you could sum up the 18, the 2, and the 10. Boys on the hike, 6 of them wear shorts. So what's the probability that boys in the whole group are wearing shorts? 6 out of the 10. And then the last question, number 7 in this section, picking a month at random. Well, we have a total of 12 months. What's the probability it starts with a J? We have January, June, and July. So 3 out of 12. In the next video, I'll cover the next section of the lesson.